So, you want to get started with Java? Let's try and demystify it. Honestly, the best way to think about it is like you're learning any new spoken language. You wouldn't just jump in and start writing essays, right? No way. First, you've got to learn the alphabet, get a handle on the basic grammar, and, grab a good dictionary. And that is exactly what we're going to do for Java today.
Okay, so let's start with the big question, the one that kind of gets to the heart of it all. You sit down, you type some code into what is basically just a plain text file, and somehow that thing turns into a real working application. How in the world does that magic happen? This is the core process we need to wrap our heads around, and it all begins with having the right tools for the job.
And that brings us to our toolkit. First things first. If we're going to write in this new language, we absolutely need our pen, paper, and dictionary. And in the world of Java, this all comes neatly bundled together in one essential package that every single developer needs to have.
That package is called the Java Development Kit, or JDK for short. Just think of it as your all-in-one starter kit. It isn't just one single thing, it's a whole collection of critical tools. And the two most important ones in there are the Java compiler, which we'll call Javac, and the Java Runtime Environment, or JRE, which is the part that actually runs your code. So here's how we answer that big question about turning text into an app. It's a four-step dance. First, you write your code in a file that ends in .java. Simple enough. Then you use that Java C tool from the JDK to compile it. Now here's the cool part. It doesn't create a program that runs just on your specific computer. Instead, it creates something called Bytecode, a .class file. This is kind of Java's secret sauce. Because this bytecode is totally neutral, the JRE can take that exact same file and run it on a Mac, on a Windows PC, on a Linux machine, anywhere. That's where that famous write once, run anywhere motto comes from. All right, so now that we have our toolkit, it's time to learn the absolute basic rules of the language. We're talking about the alphabet, the words, and the punctuation marks that the compiler can actually understand. In Java, these little building blocks are called tokens. They are the smallest, most fundamental pieces of code that actually have meaning. You can't break them down any further. It's just like in English, where a sentence is made up of words and punctuation. Well, a Java statement is made up of tokens. And you'll see these 5 types of tokens everywhere. First, you've got keywords. These are special reserved words like class or if. Then there are identifiers, which are just the names you make up for things. Literals are the actual values themselves, like the number 100 or the text hello. Operators, well, they do the work, like the plus sign. And finally, separators, like parentheses and semicolons, are what give your code its structure. Believe it or not, every single line of Java is just a combination of these 5 things. Okay, we've got our tools, we've got our alphabet. But how do we actually talk about things in our code? We need nouns. We need ways to represent and store information. And this is where data types and variables come into play. Now, in Java, there are 2 main ways we store data. First, there are the primitive types. These are the simple, basic ones. When you create an integer, for example, the variable holds the number 10, right there. But for more complex stuff, like a piece of text, Java uses reference types. And here's the twist. The variable doesn't hold the text itself. It holds the memory address, basically a pointer, to where the actual text is stored. It's a super important distinction. One holds the thing, the other holds directions to the thing. And here are those 8 primitive building blocks. Don't get overwhelmed. For now, you really only need to worry about the most common ones. You're going to be using int for whole numbers all the time. You'll use double for any numbers with decimal points, char for just a single letter or symbol, and boolean for simple true or false values. That's it for now. So how do we actually use these data types? Well, with variables. And a variable is really nothing fancy. Just imagine a box and the computer's memory that you can stick a label on. You give it a name, tell it what kind of information it's going to hold, and then you can pop your data right inside. Now, where you decide to create this box really matters. If you make a local variable, it only lives inside a specific chunk of code, and poof, it's gone when that code is done running. An instance variable is different. It belongs to an object, so every object gets its own personal copy of that box. But a static variable, that one's special. It's shared. There is only one single copy for the entire class, and all the objects have to look at that one single box. Okay, so we have our nouns, our data. Now we need some action. We need verbs and sentence structures that let our program make decisions and repeat tasks. This is the stuff that really brings our code to life. And these are called control statements. Without them, a program would just be a dumb list of instructions running from top to bottom, one after the other, and then stopping. Control statements are like the traffic cops of your code. They direct the flow, telling the program when to turn, when to loop back around, and when it's time to stop. When it comes to making decisions, you've got two main tools in your belt. You should use an if-else statement when you're dealing with tricky conditions or ranges, like checking if a score is greater than or equal to 90. It's super flexible. But if you're just checking one variable against a specific list of possible values, like is it Monday, Tuesday, or Wednesday, a switch statement is often way cleaner and a lot easier to read. And what about repeating things over and over? Well, you use a for loop when you know exactly how many times you need to do something, like do this precisely 10 times. It neatly packages the whole setup in one line. But you use a while loop when you want to keep going as long as some condition is true, but you have no idea when it'll stop. Think about waiting for a user to finally type the word quit. That's a job for a while loop. And finally, you've got these little commands to manually change the flow. Break is your emergency exit. It yanks you out of a loop right then and there. Continue is kind of like hitting the skip button on a song. It just ignores the rest of the current loop and jumps straight to the next round. And return, that ends the entire task or method that you're currently working in. So we've got nouns and we've got verbs. Now for the last piece of this basic grammar lesson. How do we package up our instructions into reusable chunks, and how do we organize our data into neat, tidy lists? That's what methods are for. A method is really just a named block of code that does one specific job. So instead of writing the same 5 lines of code over and over again, you can wrap them up in a method, give it a helpful name like calculate total, and then you can just call that name whenever you need that job done. It is absolutely key to writing clean, organized code. Now, of all the methods you'll ever write, there's one that's extra special, the main method. You can think of it as the front door to your entire application. When you tell Java to run your program, the first thing it does is look for this exact method. And that's where everything begins. Every single standalone program has to have one. It's not optional. So that's how we organize our actions. But what about our data? For simple lists of things, we have arrays. An array is just a container that holds a fixed number of items. And here are the 2 big rules. All the items have to be the same type, and the size is fixed. To get to an item, you use its position, or index, which, and this is a big one to remember, always starts at 0, not 1. And here's a little technical detail that's good to know. Even though an array can hold simple things like numbers, the array itself is actually an object in Java. That means it lives in a special part of memory called the heap. And it also means that once you decide an array is going to hold, say, 10 items, that's it. It's locked in. You can't make it bigger or smaller later. So let's just do a quick recap. We've gone over the toolkit, the JDK. We've learned the alphabet and punctuation, which are called tokens. We've covered the nouns of our language with variables and data types, and we have our verbs and sentence structures with control statements. You now have the fundamental grammar of Java down. So the only question left is, what story are you going to write?